Hello friends, today we are going to discuss a very important and a very interesting program which is the pattern printing program as well as has been discussed in the previous videos. So this program is a binary printing pattern and it's a very interesting pattern, and the code is a little bit of code has a twist, a little bit of twist in it, and let's get started with the program. It's a very interesting program. So let's get started. Let me first write the question. Wrap in C to print one, zero, 1, 0, 1, 0, and so on. So the pattern is going to be printed in this manner, in which we are going to print a 1 in the first row, a single 1 in the first row, followed by a 0 and another 1 in the second row, and in this pattern in the third row, and so on and so forth. As we can see from here that the 1 is alternating with the zeros and vice versa. The zeros are alternating with the 1s. So if we start with 1, then the next next character will be 0 to be printed, and after that 1, and then 0, then 1, and then 0, and in the next line it goes on like that. In the first row we get 1 character, in the second row we get 2 characters, and in the third row we get 3 characters, and in the fourth row we'll get 4 characters, but all will be printed in an alternating fashion. So it is a binary pattern printing program, which is quite interesting. So let us explore the nuances of this program. So let's get started with writing the program first. So first, the file inclusion directive. First, hash include stdio.h int main. Then what are the number of variables? How many variables are we going to take? See, it is in the usual manner. We are going to take suppose the number of rows, that is, we'll take a variable n in which the number of rows will be specified by the user, and another loop variable which is I, and for the inner loop variable we take j, and another variable is required which is x or y or z or abc, whatever you can take. So let us take 4 variables at the very beginning, so that let me get started with taking 4 variables. If any variables are required later on, we can add those variables later on in the later stages of the program. So let us get started with declaration of the variables. Int n for the number of rows to be specified by the user, I, j, these are the loop variables, and then x is a variable which will be assigned to a value of 1. Why this 1? Why it is not any other value like 0 or 0, 2, 3, etc. It is 1 because we will start printing the pattern from 1. So whatever we are going to print in the first line as the first character of this entire pattern, and that will be initialized in this variable, which is the x variable, which will store a value of 1. So if this pattern would have started with 0 and would have gone in this fashion, in an alternating fashion in this way, that's program is quite similar to the program which is going to be discussed now. So if you just understand the nuances of this program, you will get to understand this program as well. But in that case, what will be the difference? The difference is that the value of the x variable will be initialized to 0 beforehand, instead of initializing the value of x to 1. So let's get started with the program in our hand. So printf will give a prompt to the user to print the number of rows in the usual way. Enter the number of rows, new line, scanf, %d, %n. Then comes the logical portion of the program, that is the for loop construct starts from here. For I is equal to 1, I less than equal to n. In the usual manner we will write, nothing to explain over here. Then we enter the inner loop, that is for j is equal to 1. As you know, the j will be controlled by the outer loop variable I, j less than equal to I. Then the incremental part j plus plus, and inside this we are going to print what? Inside this, see, we are going to print the x value, and which will be increased in the inner loop. After printing the x value, we will just increase the x value by 1 modulo 2. So that if 1 is printed in the first instance, 1 will be increased by 1, and then a modulus operation with respect to 2 will be done in order to get the next 0. See, this 1 plus 1 means 2, 2% 2, that is the remainder which is returned is obviously 0. So the next value comes to be 0. And in a similar way, if we increment this 0 by 1 and again modulo 2 calculation is done, then we see that 1% 2 is definitely going to return 1. So in this fashion, we are going to print this alternating pattern, alternating bits or zeros and ones in this pattern printing. So first, let us just get the x printed first, and then we will increase the x by unity, that is 1, and then the operation will take a modulo 2 calculation to give the remainder which will be printed in an alternating fashion. Let us see what I am doing. Printf %d tab, sorry, excuse me, %d tab. What I am going to print? I am going to print the x value. So x value is initialized to 1, so 1 will be printed at the beginning, and in this case 0 will be initialized to x, and that 0 will get printed in the first instance. So this is the logic of the program, and then we are going to increase the value of x by unity modulo 2. Modulo 2 means always anything divided by 2 can just give you a remainder of 0 or 1, and this will get incorporated in this pattern. So let's see, printf %d x is equal to x plus 1 %2, then inner loop ends. We go on to print the new line to take the cursor rather into the next line, from 1 to this line, from this 1 to this line, from this 0 to this line, and so on. We take the new line, and then we are going to end this outer loop. After that, whatever remains is nothing but a formality, that is return 0 and the closing brace of the program. So just put some sample values. Suppose we are going to print 2 rows. So 2 rows will give an expected pattern of like this. Sorry, it will start from 1, 1, 0, 1. So this is the expected pattern for a number of rows when it is specified to be 2. So let us just take some sample values and explain it to you. So let me rub a little portion of this program so that I can show you the dry run. So this n, suppose n is specified to be 2 by the user, then what is the loop construct says I is equal to 1, I less than, definitely less than equal to 2. It is correct. We enter the first loop and then go to the inner loop. J is equal to 1, j less than obviously 1. So we enter the second loop as well, and then print whatever is x. So let us print the output over here. So x is 1 because x has been initialized to 1. So then the x is then again incremented by x plus 1 modulo 2, that is 1 plus 1 % 2, that means 0. So x becomes now 0, and then we go to the inner loop once again, increment j, and j becomes 1, j becomes 2 rather. and so 2 is not definitely less than equal to 1. So we come out of the inner loop, go on to print the new line, and the cursor blinks over here. We enter the outer loop once again, increment the value of I by unity, I becomes 2 less than equal to 2, perfect. And then we enter the second loop for the second time, and second loop, in the second loop j will be initialized to 1 less than equal to 2, perfect. We enter the second loop and print whatever is in the value of x. What is in the value of x? X is now storing a value of 0. So we are going to print 0 over here. And then again we are going to calculate this x plus 1% 2 in order to increment the value of x by 1 modulo 2. So x becomes 0 plus 1% 2 means 1. So x becomes 1, j becomes 2, j less than equal to 2, perfect. We print x, then we are going to print what is the value of j? 1. And then again the x plus and then x plus 1% 2 will give you another 0. So that 0 will be stored in x. We increment the j plus plus by j by unity to give the value of j to be 3, which is definitely not less than equal to 2. Condition is false. We come out of this loop, print a new line, and then again I is incremented to 3, and which is not less than equal to 2. Condition not satisfied. We come out of the outer loop and go to the end section of this outer loop block. Return 0 is not written because of the paucity of space. Excuse me for that. You very well know that there will be a return 0 over here and then the closing brace of the main section. So that will give the expected pattern. Let us match this with the expected pattern. See, for n is equal to 2, the expected pattern was 1, 0, 1, and this has been printed duly. Pattern is being printed in the expected manner. See this. Let's compare the two patterns. This 1, 0, 1 is the pattern which we are getting from this dry run, and the expected pattern was this 1, 0, 1. So these two patterns match to each other, and that proves that the program is quite right in terms of logic and is ready to be executed and ready to be run on the computer system. So if you have any doubts or queries pertaining to this program, you can well post your queries or doubts in the comment section below so that I can address those queries of yours. Thanks.